Hello students, today we will study about the real numbers and their decimal expansions. This is the topic of standard 9 chapter number 1 number systems. Okay, so in this topic now we will understand the real numbers in the total different way, right? And the way we are using is the decimal expansions, right? So in this topic we will also study about how to classify the real numbers in the two categories, rational numbers and irrational numbers, based on the decimal expansions. So first of all, we will study about some of the rational numbers and the decimal expansions. So first rational number is 10 upon 3. Now what will happen if we represent this in the decimal form? To represent it, we now divide the 10 with 3. So, if we divide 10 with 3, what is the quotient here? 3 3s are 9. By subtracting 9, we will get 1 as remainder. Right? What is the remainder here is 1. Now, for the division, we will take here the decimal point and take a 0 here. Right? So, it will becomes now 10. So, now we can again divide it by 3 3s are 9. Again the remainder is 1. In the same way, if we divide further by taking one another 0, again we will get 3 3s are 9. Fourth step, again we will get 3 3s are 9 and the remainder is 1. Notice one thing here is that every time we get remainder is equals to 1. Here the remainder is 1, again the remainder is 1. Again the remainder is 1 and last again it is remainder is 1. Still it is not actually completed, it is not divided, it is continued. If we divide, then this pattern will continue 3 3 3 3, right? It is not here terminating, it is continuous, right? But we stop here because we will understand how to represent this, right? Second one is 7 upon 8. If we divide 7 with 8, we know that we cannot directly divide it. So first of all we will multiply it with 0. So 8 zeros are 0. Now there is remainder is 7. Now we take decimal point and we can add here 0. We can put 0. That's why it is become 7070. Now 8 8s are 64. The remainder is 6. Again we can put 0 here. So now it is 8 7s are 56. What is the remainder? 4. Put 1 0 again. We will get 8 5s are 40. See, the remainder is 0. Now here this decimal expansion stop here. 0.875, right? Because our remainder is 0. That means we perfectly divide the 7 with 8. Here we cannot perfectly divide 10 with 3 because remainder is repeating itself. It never stops. It will continue. What is the third case? If we divide 1 with 7, see, we cannot directly divide. So first of all we will take 0. 7 zeros are 0. Then to put here 0, we will take a decimal point. Now it will become 10. 7 1s are 7. What is the remainder? 3. Again we can put 0. Now 7 4s are 28. Remainder is 2. Again put 0. It will become 20. 7 2s are 40. Now the remainder is 6. So we can put 0. It will become 60. 7 8s are 56. Now again the remainder is 4. We can put 0 here. So now 7 5s are 35. I have taken this portion here. See, 40 minus 35. It will give us 5. Now again put 0. What will happen? 7 7s are 49. What is the remainder? 1. Now you may think that what will happen if we further divide it? If we continue this dividing process, what will happen? See, here what is the remainder? 1 and here is the remainder is also 1. If we further divide it, then we get again the remainder as 3. Then we get the remainder as 2, then 6, then 4, then again 5 and again 1. So in the quotient, this pattern will repeat itself, right? So what is the quotient now is 0.1427857. This is not perfectly divided in the same way as of first example. This is continued, right? So if we further divide it, we can get this whole numbers again here, right? 1427857, then again 142857, then again 142857. That means this much of block repeats itself in the quotient, and remainder also repeats itself as 1 3 2 6 4 5 1, like this. So what we can notice from these three examples, first one is remainder either becomes 0 or repeating, right? Here you can see that remainder becomes 0 or it repeats itself, like here 1 as a remainder repeating itself, and here the block of remainders repeating itself, right? Second point, string of remainders is less than the divisor. That means, see here, this 3 3 3 repeating itself. That means only one number repeats itself and it is less than this 3. That means in this repeating string there is only one digit and 1 is less than 3, right? Here also the repeating string, how many digits are there in the repeating string? 1 2 3 4 5 6, and it is less than the 7, right? So in all other cases other than this, if you divide like this, then you can get the same result, right? What is the next point? See, 10 upon 3, we get here 3.333. This 3 is repeating itself. That is why we can put a bar on the 3. It depends on how many digits repeats. Here 3 is repeating itself. That is why we put a bar on this 3. The meaning of 3.3 bar is 3.3333, like this. Okay? In the same way, 7 upon 8, we get its decimal expansion 0.875. Here no need to put the bar because its decimal expansion stops here, right? Third case, 1 upon 7 is equals to 0.142857 bar. The bar is on the 6 digits 142857. Why? Because these numbers repeats itself. So we cannot write down it, right? So the easier way to write down the decimal expansions of this type of number is to use the bar, right? So now these things is possible for every rational numbers, right? So the decimal expansion of rational numbers are either terminating decimal expansions or non-terminating repeating decimal expansions. Terminating means, this is the example of terminating, when remainder becomes 0, and this is the example, first and third is the example of non-terminating recurring. Recurring means to repeat itself, right? So what is the conclusion for the real numbers and their decimal expansions is, see here. Here is the conclusion. So decimal expansions of real numbers are of three types. First one is terminating. Terminating means the remainder becomes 0 and the quotient we get a number 0.875. There is no bar on the numbers. That means there is no number is repeating, right? Second example is 11 upon 4. The decimal expansion of 11 upon 4 is 2.75, right? Second type is non-terminating repeating or recurring, right? Both are the similar words. So examples we have seen earlier is 10 upon 3. 10 upon 3 is equals to 3.333. That is why we represent it as 3.3 bar. Second example is 14 upon 11. Here 14 upon 11 means 1.272727. Now see, this block of 27 repeating itself. That is why we put a bar on the 27. So 14 upon 11 we can write down as 1.27 bar. Right? And the third type here is non-terminating, non-recurring. Right? So this example is root 2. Root 2, the decimal expansion of root 2 is 1.414235, and there are many other numbers are there. But one thing you can notice here that this type of pattern is not there. The digits are totally different. We cannot make this kind of pairs in this, right? Second example is of pi. Pi is equals to 3.1415925, and in the same way there are also many numbers are there. In both the cases, root 2 and pi, this type of pattern we cannot find, right? So there are three types of decimal expansions. Once again, terminating, non-terminating repeating, and non-terminating non-recurring. So how to classify the real numbers in the rational numbers and irrational numbers? If there is some irrational numbers, then its decimal expansion is either terminating or non-terminating repeating. Repeating means this type of numbers. Its decimal expansion is continuous, it will not stop, but there is a pattern, that means recurring, right? This value repeats itself. And if the decimal expansions of number is non-terminating, non-recurring, that means there is not any kind of pattern, then that number is called the irrational number, right? So in this way also, based on the decimal expansion, we can classify the real numbers in rational numbers and irrational numbers, right? So this is all about the decimal expansions of real numbers, right? Thank you.